Thank you, Natasha, and good morning, everyone. Before I jump back to where we started, sorry, to where we stopped last time, I just wanted to do a quick review of what we were doing. So in the last session, we discussed a few concepts that we are going to use throughout the week. So we talked about what are data sets and data tables. Can anyone remind us of what is the difference between a data set and a data table? If the difference between the two is not clear for everyone, then I can also recap. Mavis, were you going to say something? Okay, I get it. We're just restarting and everyone is feeling shy. So let me open the presentation here and let's go through a quick recap of what we discussed on Wednesday. Okay. I assume you can all see my screen now. If you cannot, please raise your hand and I will try to fix it.
We can see it, Luiza.
Great, thank you. So these are some of the concepts that we talked about on Wednesday. So starting with a data table, which is great. I see that someone is speaking. Let's see. Yes, thank you, Emmanuel. That's exactly it. So a data table is a way to organize data in a tabular format, so in rows and columns. And a data set can be composed of one or more data tables. So a data set is the set of data that we have for one particular project. And it can be just one table, it can be multiple tables, it can be tables and other forms of data. And then the two other things that we discussed that were important were the idea of what is a variable and the idea of what is an observation and a unit of observation. So variables are all the different aspects or the different characteristics of our subjects that we are collecting data about. So in the examples that we looked at, we included things like age, like their positions, like their names. These are all different types of information that we're collecting about the individuals that are present in our data set. And then an observation is the collection of all the information that we have about one individual. So if we took someone in our data set called Luiza, we could get then the information about Luiza's age, Luiza's position, when she joined the public service, her date of birth, and so on. And that would be one observation, the observation that talks about Luiza. And then we talked about a unit of observation, which is the concept of what is what one observation in a data set represents. So each data table will ideally represent one type of individual. And understanding what the unit of observation is will be very important for us to understand how to handle our data. So some examples that we could see is that we could have a data table that is at the individual level. So each entry is one person. But we could also have a data table that shows a combination of person and position that they occupy. So if someone was promoted over time, we would have more than one entry for that person, because each observation would represent the time that the person spent in a given position. One other thing that we talked about was a unique identifier. Who can tell me what are the two characteristics that we look for in a variable so that it can be considered a unique identifier? Feel free to unmute yourselves or to write down on the chat. Elizabeth? Okay, so we have an answer here from Mavis. It says that a variable, to be a unique identifier, should not be repeated. That is correct. So we say that there are two characteristics that a variable must have in order to be considered a unique identifier. It needs to be uniquely identified, and it needs to be fully identified. So what Mavis has just said here is that the variables should not be repeated. That means that for a variable to uniquely identify the observations, we cannot have two values of this variable. We cannot have two occurrences of the same value in the variable. So if two people have the same name in my data set, then the name is not a uniquely identifying variable. And then the other characteristic that we look for in an identifying variable is that it is fully identifying. Who can tell me what that means? For a variable to fully identify the observations in a data set. Again, feel free to either unmute yourselves or to respond down in the chat. Yes, Maxime? Did you want to respond my question about what makes a variable fully identifying? I guess not.
Hello.
Hi.
Yes, so can you hear me?
Yes, I can.
Yes, I'm saying that for a variable to describe as such, it means that variable has to be unique and should be able to fully describe something that you not have ambiguity or describe fully something that you want to put across. Yes.
Yes, that's great. That is exactly the definition that we're looking for. Can you give an example of when a variable would not be fully identifying, or when the information would not be complete, as you said?
Okay, let's say you are, an example could be for a variable not to be unique, it means that that variable, I mean, you could get 2 or 3 people using, or when you are looking for that variable, it can be traced. You can trace it in other information that you have. Yes, so it will not make it unique, and it will not give you a description of a particular thing that you are looking for.
Yes, right. So if we have duplicated values, or if we have a value that occurs more than once in our data set, then it is not uniquely identifying, right?
Yes.
Great, thank you. And then another thing that could happen as well, that even if all the values are unique in our data set, if we don't have a value for a variable for a few observations, that it would not be fully identifying. So if I am trying to use the staff ID number for everyone in this meeting, and I do not have the staff ID for one of you, then that could not be used as an ID variable because the information is not complete. So it is not fully identifying. And these were the core concepts that we learned, that we discussed on Wednesday. And then what we started doing was we started creating a data map. So the way that I try to organize my data work is that I receive data, and then the first thing that we're going to do is we're going to open this data set and try to understand what are the variables that it contains, what is the unit of observation, what is the uniquely identifying variable, and then so that we can structure the way we think and communicate about this data, we are going to start drawing a data map. And a data map consists of 2 or 3 pieces of information, depending on how complex your data is. The first piece of information that we started creating last Wednesday is a data linkage table. And basically what it is a list of all the data tables that are present in our data set and some information about them. Like what is the unit of observation, what is the unique ID, where we have saved it in our computers. And then today what we're going to do is we're going to draw a data flowchart, which basically describes how we're going to use this data that we have collected to achieve some indicator or some analysis that we are trying to perform on that data. So last week I shared with you, last Wednesday, I shared with you 3 data sets, 3 data tables, 1 data set containing 3 data tables, and they were these 3 that I have here. So we had 1 data table that had a list of everyone that works in a department or a firm. So each line represented 1 employee, and then we had a bunch of variables about each of them. We also had a table that showed the recruiting costs. So that is how much money this firm or this agency has spent with different ways to recruit people. And we also had a salary grid that basically show what is the yearly or hourly salary that people in different positions receive. What we started doing last week is that we created two things. We created, sorry, I keep saying last week. It looks like it was so long ago. So we started creating this data table, with this data linkage table, sorry, that lists all the different data tables that we have, their units of observation, the unique ID that we have in them, and then how to connect them to one another. So this is our data linkage table.
Yes, please. Your name?
My name is Smith.
Okay.
Yes, I'm with the recruitment training and development.
Okay, that's muted now. Great. Okay. So we created this table where we described all the different data tables that are present in our data set. And then I asked you to also think both about your data and or the data we have here, depending on which one you were working on. What are the kind of analysis and the kind of indicators that we want to create out of this data? So what we are going to do next is that we're going to create a map of how we get from these data sets that we have here to the final data set containing the indicators that we would like to create so that we can run our analysis. So I'm going to ask you, if you haven't yet, to open the data sets, the data set that I shared, or whichever data it is that you will be working on during the rest of this session. I'm going to give you a couple of minutes to do that, and then I'm going to start explaining how we can create a data flow chart. Once we're done with the explanation, we're going to try to use one example from either this data set or one of your data sets and write down what that example would look like if we were to create a data flow chart for it.
Does anyone need me? Oh, sorry, Luiza. Does anyone need me to resend that data? If so, can you please raise your hand and I can email it back out?
Thank you, Adrian. So if you don't have the data with you, please raise your hand and we'll make sure to resend you so that you have the material to keep working on today. While you do that, does anyone have any questions about the recap that we did now or about the material we discussed on Wednesday? Adrian, we have at least one person that does not have the data. Maybe can you just resend it to everyone?
Sure, I'll send it out.
Thank you. Okay, so let's talk about a data flow chart and what it is and how we can build one for whenever we are creating a new data set. So a data flow chart is basically a way to communicate or to visualize the key steps on data processing. So what it does is that it creates a mental model, so something that we can share and we can refer to that explains what is the necessary work that needs to be done in the data so that we can achieve our analysis or we can create our indicators. It is a running joke among data analysts that the thing that takes the least time, or the thing that we dedicate the least time of our work, is on actually analyzing the data. What takes the most time is preparing the data so that it can be analyzed. And this can be a very complex process depending on the type of data that you have and the type of indicators that you want to create. So what this flowchart does is that it shows you exactly what you need to do before you start doing it. And it's totally fine and even encouraged to keep making changes to this plan as you find out that you have new needs, or that you skipped a step when you first thought about it. That is exactly what this is here for. So the way we create this data flow chart is that we start by listing all the data tables that we need to create one piece of analysis. And then we go back to all the raw data that we have. So all the original data that we have. And what we're trying to do is we're trying to connect these two dots. How do we get from the raw data that I have to the final data set that I need to analyze and create the report that I need? What we're going to do as we trace back the steps between these two data sets is that we're going to make note of all the steps that are important, and more importantly, of all the tasks that are error prone. So where can things go wrong? Where can I make mistakes that will hinder the quality of my data and my results? This figure that we have here is the data flow chart for one particular piece of analysis for a paper that I worked on many years ago. But as you can see, I started from 7 different data tables, and then I combined them in different ways. So I put them all together, all the observations together, then I aggregated them, and in the end, I had one single data set. That is the data set that I used to create the graphs and tables for my final paper. So you have here the original data sets in blue. All these little containers here are the intermediate data sets that I created so I could get to the final data set. And in orange, you have the most error prone or most complicated pieces of the work. This is where things can go wrong. And so I make a lot of notes on what I need to make sure to do so that I don't have mistakes on my data as I do that. So the first thing that we're going to do to get to this final image here is to list all the final indicators that we are looking to create. Remember, on Wednesday, we created a data dictionary for the raw data. This is the HR data set. And we created a data dictionary where we listed all the variables that were present in that data and what they meant when they were difficult to understand. So what we are going to do now is we're going to start listing all the variables that we want to be present in our final data set, the data set that we will use for analysis. And we'll create a data dictionary for that as well. So what I want you to do is for you to list for the data that you have all the final information that you need in there. And I'm going to give you a couple of minutes to do that. And then we're going to discuss what they are. And I know that at least some of you, I think Daniel mentioned that he had a data set that is very similar to this one that we also have. So we can use this one as a way to calculate that, to kind of use this one as an example to make sure that we understand how to get to your indicators as well. And if you don't have your own data set, then you can use this one. And I'm going to start writing down here some ideas that I remember came up during the last time we were talking. Feel free to unmute and ask questions if they come up as you start writing down your indicators. So one of the things that we discussed that were mentioned last Wednesday that we may want to know was the average age of the staff that is occupying different positions. So I'm writing this down here so that we can think about how to retrieve this information from our data. And the other thing that I'm going to write down here is the cost of recruitment per person recruited. So we know how much it costs, how much the firm has spent on each of these recruiting sources. And we know how many people have been recruited through them. So what we're going to calculate is how much it costs to find one person through one source. Did you think of any other indicators that we may want to calculate through using this data set and that it may be useful to include in my examples as well? Or do you have any questions about the examples that you were creating? Okay, so let's get started. We have here a list of the final indicators that we want to create. And now let's write down what is the level of observation that is represented for each of them. This is the indicator. This is the question it answers. Now, what is the unit of observation that we need to have to be able to identify, to be able to answer these questions? If I am trying to calculate the average age of the staff occupying different positions, so for each position, I want to know what is the average age of staff. Once I create this table, what is going to be in the rows of this table? What is the final unit of observation that I want? Let's say that I'm creating this table here. It's going to look something like, what is the position and what is the average age?
I think it's the average age.
Sorry, say that again.
I think it will be the average age that you look for.
So the average age is going to be a variable in this data set.
Mm-hmm.
And what is going to be each row? What is represented on each of these rows?
So that'll be different positions or their, is it grade or position that they occupy per the average age?
So the unit of observation that I have here is going to be a position. And then the variable that I'm going to have is, so the column will give me the average age. Very good, thank you. Now let's
You're
say that I
welcome.
am doing, sorry, go ahead. Aisha, you wanted to add something?
No, I said you are welcome.
Great. Okay, now let's say that we want to do this other table which says the cost of recruitment per person recruited. In this table, I'm gonna have something like, I'm gonna have what is the source of recruitment? I'm gonna have the total cost, the number of people hired through this source, and I'm gonna have then the average cost per person hired. Oops, let me show this here so you can read it better. So this is the table that I need to be able to calculate this indicator. So what are the variables in this table? And then we have source one. What is the level of observation in this table? What is represented in each row? In this table, I have now 3 observations, so 3 rows, and each of these rows is describing what? It's describing the total costs related to what? It's describing the number of people hired through what? And it's describing the average cost of what?
Yes, hello.
Hello.
We are describing the cost of recruitment. And as you have said, we have identified 3 sources. So we try to calculate how much it will cost or how much it costs us to recruit an individual based on the source.
Right. Thank you, Daniel. That's very good. So the unit of observation here is one source of recruitment. And then we have the variables that are total cost, number of people hired, and average cost per person. Does all this information make sense for everyone? What we're going to do next is that we're going to see what are the steps that we need to go through to be able to actually get this final table that we were looking at here. Does anyone have any questions or would like to add any other indicator?
Hello, Luiza.
Yes.
I'm not sure if this Alan.
Alan.
The same. I'm not sure if I'm using the same data set, but I'm looking at the gender as well.
Mm-hmm.
The gender distribution. Probably that could also be an indicator.
Right. So what can you give me an example of what we may want to calculate using gender? What indicator we would like to see?
So okay, we'd like to see the average. Hold on. Okay, average cost of recruitment per male or per female.
Okay.
I don't know if that's.
So we would like to see how much does it cost to hire a woman? Or how much does it cost to recruit one woman on average? And how much does it cost to recruit one man on average? Okay, so if we were doing this, can you describe, Ellen, what the final table would look like, what we would have on this?
Please, can you come again? I'm not getting you
Yeah.
clearly.
So you remember, so for the other tables, the other indicators that we described, we were trying to create a table that said, this is the position, this is the average cost. Sorry, this is the position, this is the average age of staff. Or we wanted to say, this is the source of recruitment, and this is the average cost. If we were to answer these questions that you are trying to describe, so if we wanted to know how much it costs to recruit one woman and how much it costs to recruit one man, how would the final information be displayed?
As displayed as an indicator, do you mean as an indicator? I'm not sure if I'm getting really what you're saying.
Right. So let's say, so for this first indicator here, we would have something like this. This is the position and this is the average age. So in the end, what we would show would be a table. So we have an accountant and the average age is 35, and we have a manager and the average age is 50. So we would display this information in the form of this table here.
Okay, hello. Can I come in?
Sorry, there's a little bit of echo. Please go ahead.
My screen is not moving.
Hello. Yes. Yes, Alan, I think what we are trying to establish is the gender and how much it will cost to recruit each one. So it will be gender and average cost of recruiting based on sex or based on gender.
So we would have here woman and then man, and then here we would have an average cost of, I have no idea.
Yes, average cost of recruitment, or average cost. That would be okay. Similarly, hello. Yes,
Yes, Daniel,
similarly, I think we can also look at the first one. We looked at position and average age. We can also look at position and average cost of recruitment.
Yes, we could also look at average cost of recruitment per position.
Per position, yes.
Yeah. So that's very good, and these are just some ideas, and we could go on and create a lot more indicators. I think this is a good starting point for us, and we'll just go through one or two examples, and then I'll also, if you want, we can discuss how we would go for the other examples. So in here, we would have the unit of observation would be unit of observation would be the gender, and then the average would be probably the total costs, the number of people hired, and the average cost per person. And same here, how much does it cost to recruit one person for each different position? Okay, so as you can see here, these two indicators, for these two indicators here, the average cost of recruitment per position and the average age of staff occupying the different positions, we have the same unit of observation. So when we are organizing our data, we would probably put these two together in the same table. So we would have something like position, average age, and average recruitment cost here. So these two would be in the same table. Okay, so here we have a list of our final indicators, and our final data sets. So we want, in the end, by the end of our data work, we want to create 3 different tables, one showing one at the level of the position, one showing different sources of recruitment in each row, and the other one showing different genders at each row. Great, so what do we need to do next? Oh, we actually have already done it. We need to group indicators by level of observation. So basically what we want to know, so in here, we have 4 different indicators. And we will group these 2 into the same data table because they are representing the same unit of observation. So we have 4 different indicators, but 3 different data tables. Because we will create one final data table for each level of observation that is relevant for analysis. And what we want to display in our data flow chart is how we are going to create these data tables. So let's try to do this, and the process to create each of these different data flow charts will be a little bit different depending on the type of information that we are trying to create. This is more of an art than a science, but what matters is that as a group and as a team that will be working on the same data, we are discussing how it will be created, and we are understanding each other in terms of what are the steps that we need to create. Okay, so for us to be able to do this, we need to understand what is the source of information that we need for each of these indicators or each of these final data sets. So for example, I'm going to reduce this so we can keep writing. So if I want to calculate the average age of staff occupying different positions, where will this information be coming from? I have 3 different data tables originally: the recruiting costs, the salary grid, and the HR dataset. Where can I find the information that I need to calculate the average age per position? I'm gonna organize this like this. So this is the original information that I have. I have recruiting costs. I have all the information on the HR data set, and I have the salary grid. So in here, I have all the information that is originally available for me. If I want to calculate the average age per position, what of all these variables that I have listed here and here, which of these do I need?
Hello.
Yes, Daniel, please go ahead.
Good. You need to look at the positions, list of the positions that are available in the data, and then look at the date of birth, because that's the only source of age, source of data we can get the age profile of the employees from. So date of birth and then position.
Great.
Thank
So
you.
I'm gonna start. I wish I could kind of draw this, but I'm gonna draw this on. I usually, when I do this training in person, I would be actually drawing on a board, but I don't think that will be very useful for you. So I'm gonna do it like this. I'm gonna improvise here. Let's see. We are starting with the HR data set. And we want to calculate the average So from the HR data set, I'm going to get a smaller data set that will contain the age, will contain the date of birth and the position. I'm gonna go from here to here, okay. Date of birth and position. Great. Okay, so now I started from a data set that had a lot of information, and I extracted only two pieces of information: the date of birth and the position of the person. What do I need to do next? How do I calculate the person's age? I want in the end to calculate the average age per position. So starting from the date of birth, I need to calculate the age so I can get the average age. How do I do that? I know it's a silly question, but we are trying to write down all the different steps that we need to take in our data work process here.
I think let me add on to what Mr. Daniel said. In a data set, we also have the actual ages of the people. So probably we don't need to calculate the age.
So we just extract the age from this data set instead of getting the date of birth. We just use this one instead.
Yes, that's what I think.
This way we can skip one step.
Yes, it's true. So once we have the age, then we don't need to waste time with it. But what we need to do is that we need to list all the positions and then get all the ages of number of people who fall within that age. Let's say if you're looking for senior accountants, then we need to identify all senior accountants in the data set and then get get their ages to proceed.
Exactly. So we have this here, right? So we have the position and we have the age. So I am not an expert in Excel. I haven't used Excel in a very long time, but I think we could do something like we can insert pivot table. Let's see if I know how to do this. And then we are going to calculate, in each row is going to be one position. And then the columns, we're going to show the age. Know the values. See, I don't really know how to do this. Values are going to be the age, and instead of the sum, we are going to show the average. Okay. So different software will have different ways to calculate this. I'm just using Excel here because this is what I already had open. But basically, this step here, the step that we are indicating here will vary depending on what software you are using. So how exactly this will be done will depend on what software I am using. I'm just going to make a note of that. Okay. Okay, so now we have the average age per position. That was the first. Where is the list of, okay. That was the first indicator that I wanted to calculate. So to create this data, all I needed was the HR data set. So I started from one data table and I just simplified it to get the final indicator that I needed. How about the average cost of recruitment per position? What are the starting points that I need? Where will I start from to be able to create this indicator? I see I wrote here that what I need to create, what I need to have in this table is I need the total cost per position, the number of people hired, and then I can calculate the average cost per person. How will I get the total cost per position and the number of people hired from this set of information?
Hello.
Yes.
Is that a question to be answered?
Yes.
Sorry?
Okay, yes.
You want how to calculate the average cost of a position? Is that what you mean?
Yeah, so the let's see, what does it say here? How does it cost to recruit one person? So yeah, so in here I'm talking about recruitment costs. So basically we were looking at these costs here and then trying to get a sense of how much it costs to hire one person to a given position.
For a given cost to one person to a position, if
Yes.
the total cost is known, just a matter of dividing the total cost by the number of, people who are being recruited. If the cost elements are not different, if it's uniform. For instance, if they are recruiting about 20 people for one position, and the unit cost is a 50 series, just multiply 50 series by the 20 and divide it by the number, then you get for a single person. They are not straightforward, or what is it?
Right. So we're assuming here that we're just calculating the average costs. So we're assuming that we're gonna need we're gonna have the total costs, and then what I'm asking is, how do we get a sense of how do we count the total cost of recruitment and the number of people hired based on this original information that we have?
So if we're talking about total based on different positions, for instance, from accountant to say principal accountant. So in that case, we have different positions and different unit costs. So the cost of say from accountant to senior accountant to principal, then that is 3. We sum the total of the 3 together and divide by the number of this. So in that case, you get the unit cost per. Oh.
Yes. Okay, so let's see what we are starting from an HR table. And we also have 2 other data sets in here. One is the recruitment costs. And the other one is the salaries. And what you are telling me is that what we need to have to be able to calculate the average is that we need to have the total cost, and then we need to have the total number of people in each position. And based on this, I will be able to calculate what is the average cost per position. Is this right? Is this a good summary of what you were saying?
Yeah, that's what I was saying. But if you get that cost,
Sorry, say that again.
Yeah, that's what I was trying to say. But if you get that average cost, does it mean it doesn't relate to various positions? Because that one is going to be on the 3 positions and giving you an average of recruiting a person. So if you add up the totals of the 3 positions, that will give you a picture of the average cost of recruiting one person to the various positions. That's just an average cost.
Okay, great. So we know how to calculate the average cost per position at the we know how to do the last step, right? So to be able to calculate this last step, we need to get to this previous step here, where we have the total cost and the total number of people in each position. How do we get the total number of people in each position? From which of these three data tables do we get that?
I think we can get it from the HR data.
Right. So from
Yes.
here.
Yes.
Great. So we're gonna get here, we're gonna get this one. And how do we calculate the total, we're gonna get this one here. And how do we calculate the total cost of recruitment? From which of these data sets do we start?
From the recruitment cost data.
Okay. So we have this recruitment cost data here. What we need to decide is how we are going to combine this data with the HR data. And this goes in the direction of what Arjulolo was saying, which is, how are we going to calculate the total costs? We can simply sum all the costs all over the year and assume that this is the total cost, average cost in a year of hiring someone. We can also combine these costs to how each person was hired. Where is that? We know here how each of these different people were hired. What is the source here? How they were found by the firm. So we can also combine them through here. I guess these are the two assumptions that we can make in our data. So basically, we can assume that all costs are equal to everyone, or that costs differ based on the employee source. And then, based on that, we would write down the next steps that we are going through here. So there are two different ways of getting to this data set here, is that we can either merge add all costs in a year, or we can combine recruitment costs with the source of employment of each hired. And so basically we're not using this salaries data set, so I'm removing it from our image. So what this is, and there would be other steps here. So we could either add up all costs and then assign that cost to the whole roster of staff, and just assume that the cost is the same for every new person hired, and then the average cost per position would depend on how many people I have in each position. Or I could take into account that different positions are hired through different hiring sources, and then I would have a more refined measure of the average cost per position. And I mean, there's no right and wrong here. These are just different assumptions that we would make to calculate these indicators. But I don't want to get too much into the weeds of how we calculate these indicators, or like what are the assumptions that we are doing. I just wanted to go through this process of actually creating this image, so we can see that we understand how to calculate this. And as we talk about the process, we are also, making explicit what are the assumptions and what are the tricky parts of our data work process. If I was trying to just calculate this before I stopped to think about it, I would probably not be able to understand that I have different ways of combining the data, and that there are different assumptions that I want to make explicit as I calculate it. So how we would, in the end, which of these two ways we would choose to go about creating the data is entirely up to us, and we can decide this based on what we want to do with this data. But what I wanted to go through with you was just the process of thinking through how to create it, so that you can see how important it is to think about the kind of indicator that you are trying to create in ahead of actually creating it. So basically what we have done is that we have now listed all the original data sets that we had here, and we are trying to think about which of them are relevant for us to get to our to the indicators that we want to create. And we also used the data dictionary, which was the list of all the variables that we had. We used it to create the information that we needed. So we found where is the age, in which data set is it located? How can I combine these two data sets? Is something that we looked at before when we did the data linkage table. We saw here, we use the employment source to connect recruitment costs to the HR data. So basically, the conclusion here, or the point that I wanted to get to, is that we want to think about this before we actually start to calculate our indicators, because it will help us understand what information we need and what information is available, and if we need to get more data, or if we can just get around to calculating the indicators that we're interested in. Two things to keep in mind as we think about this this data map is that there are two types of operation that we do with the data that are more error prone. That is where things can go wrong if your data is not very well organized. The first one is when you are combining two different data tables. So you saw that here, when I calculated the average age, doing this was super simple. Like, what if you know what software you're using and you know how to use that software, then actually creating it is not a problem. But even if you know the software very well and you know what you want to do, this step here of combining two data sets is something that you need to think through, and that can be quite complex. So you need to make sure that you understand how you are connecting the data sets, and that and what it means to connect to data sets in one way or another. The second step that can be kind of tricky is when you are changing the unit of observation from one step to the next. So in here, we had data that was at the level of the individual, and then we ended up with data that was at the level of the position. So we aggregated the data and changed the unit of observation. This was a simple case, but whenever you're doing that, you need to make sure that you understand that you are changing the unit of observation, and that sometimes there can be errors when you calculate this. And that kind of error that can happen really depends on the software that you're using. So I will not get into a lot of detail about what they are here, because I understand that different people in here may be using different software. But basically what you'll have at the end of this process is that you'll have, well, this is a very simple version, but you can have something like this. You will have a map that shows you what are each of the steps that you need to go through to create, sorry, here. What are each of the steps that you need to go through? So, you can organize your work accordingly based on this plan that you have put together. And this is also a place for you to think about what could go wrong, since this will help you keep track of the quality of your data. Yes, Daniel, did you have a question? No, okay. So this is just for you to have a sense of how to create a data map for your project. We have used a toy example here that may not necessarily be exactly what you are trying to do. But the point is that for your next project, you know how to think about the process of processing data and calculating indicators. So there's two things that we can do now. We have half an hour. We can take time for you to try to do the same exercise for your data. Since we used my example here, if you want to try to create a data map for your own data, and you have data that you're going to work on, we can take time to do that now, and then you can ask questions as you do that, and we can discuss that together. Or I have another presentation as well that we can go through that basically discusses how to organize your folders and your data inside your computer, so that you can collaborate with other people on data work. I will let you decide what you prefer to do, because that's I don't know the specificities of each of your projects, so you can tell me what is the most relevant for you. Or let me phrase it in another way. Are there enough people in here who would like to take time to do to create a map for their own projects, or should we just go ahead with the presentation? So maybe raise your hand if you have a project that you would like to create a data map for it now. Yes, Ajalo.
I would suggest that we go ahead with the presentation, please.
Okay. Let's do that then. Okay, so this next presentation is about how to manage data. And this can be very complicated depending on what kind of data set, what kind of data you are using. If you have very large databases that have different units of observation that are related to one another, that is what we call a relational database. And there are very complex and very specific softwares that are used to handle this kind of data. What we are going to talk about today is when you're using a more simple kind of data, similar to the one that we were looking at examples for this data map. So the reason why it is important to think about how to organize your data is that it is very easy to get lost in your own project and then spend a lot of time explaining, for one person having to explain to the other, this is the file that I used, this is how you, this is where you find it, and this is where I put the results. And then, you know, by the time you are trying to create a presentation or a report, you have to keep asking your colleague, where are the figures that I need to include in my report? So this is one of the problems that we're trying to solve with this. The other problem that we're trying to solve is how to find answer to questions. When we do data work, we often have to make decisions that can make a lot of sense at the time that we do them, but that will not necessarily remember when we need to think about them again. So for example, in the example that we just discussed, we talked about two different ways of calculating the total cost of recruitment. And whatever way we decide to calculate it, it's important that we write it down and that we know how to find the answer to why we calculated it in this way. The reason for that is that you may not remember in a year from now when you're trying to do this again for the costs of the next year. And then you need to think, how do I calculate this again? And then you think that what you did before doesn't make sense. And then you have you are super scared that you delivered the wrong numbers in your last report. So the second problem that we are trying to solve is how to find answers when you need them. And the third problem that we're trying to solve with this system that I'm going to suggest that you use is that sometimes you have a number and you know how you arrived to that number. Let's say in here we have, where is the HR data set? Okay. So we have this table, and we know what are the average ages for each of these different positions. Now, let's say that I put this table in a report and that I delivered this report to my boss, and now they know they have these numbers. But in the next year, I receive a new data set that has different ages in here. And when I try to recreate this file, I cannot, because the data has changed and I don't really know what data I use on my last report. So this is the last problem that we're trying to solve, which is which version of my data did I use to create this indicator? And was this the correct version? So what I'm going to talk about for the next 20 minutes or so is basically what is a system that we have come up that we use in our department to organize the data so that we always know what are the answers to these questions. And what is important here is not that you use exactly the same system as we use to organize your data, is that you understand that it is important to have a system. Because at first, when you're receiving data, it may seem that it's very trivial to just store it wherever is most accessible in that moment. But then a year or 2 years from now, you and your colleagues may not remember what exactly you did. So it's important to keep track and to agree and think about the organization of your folders actively. So basically what we need to do is when we are starting a new project and we're starting to receive data is to think about and agree with our colleagues on a few things. So we start by asking ourselves how we will receive data, what kind of software we will use to process and analyze the data, who will be working on this, and will they be working in a computer, will be working in a server, and then how will you keep track of all the different files that you are using. We will talk about version control. And finally, how you will name your files and folders so that you know how to navigate them and everyone in the team knows how to navigate. So one of the reasons why we started to create a system in our department to organize data is that each of us work in a lot of different projects. So if each project has its own way of organizing things, whenever we are switching from one project to the next, it becomes very difficult to remember how things are structured in each different project. So what we have done is that we have created one way that all projects use to organize the data. And then we all know where to find things regardless of which project we are working on. And when we're working with different people in different settings, each of us has a preference. For example, some people prefer to take notes on a notebook. Some people prefer to take notes on a Word file and then save it on a folder. What is important is that everyone agrees on what system will be followed, so that if any person in the team needs to find some notes, they know where to find them. Okay, I have already covered this one. Okay. So what I have here is a diagram of how we organize the data in our department. This is what we use for research data work. So it may not fit exactly your needs, but it's something to kind of keep in mind in terms of how we call different tasks that we are doing. So one of the things that we have discussed today is this first step, which is the design, where we are identifying data needs and creating a data map. Then we will receive data, we will process data, analyze it, and then create a report or a paper that will be published. You will see that we name our folders making references to each of these steps. So at the end of data processing, we have clean data, and we'll have a folder for clean data. Then we construct indicators, and we will have a folder for constructed data. Then we are going to export outputs, and we'll have a folder that is called outputs. So we organize our files thinking of the way that our work is organized. So the most, I'm going to mention here only a few steps of this process, which I think are universal and apply to any kind of data work. So what we call data acquisition is when you are receiving data that will be used to answer your questions. So this can be data that you are collecting if you're doing a survey. This can be data that you are receiving from another department that already has that data, but either way, we call this data acquisition. Then this data may be received in any format, depending on how the data was collected and stored before you get into it. But the first thing that we want to do is we want to import this data into whichever software you will use. So for example, maybe you receive this data in the form of a text file or a CSV file, and you want to import it into Excel or into Stata or R, because this is where you will analyze your data. So basically, when you're importing data, you are making sure that the data is saved in the format that you will be using from here on out. And then you are cleaning data, which basically means you are exploring it and making it more efficient to be used with the software that you have created. And all of these things are not things that we have discussed so far. What we have focused on in the material that we saw before was how to get from the clean data to the constructed data. So this is what the data map is showing. How to get the clean data into the format that you need to respond to your questions. So what we call construction is taking data that was received in whatever format it was collected, and then transforming it into indicators that can be analyzed. And then what we call analysis is exactly the process of creating these tables and figures that we'll include in our papers or reports. Questions so far? Does this apply to what you are doing? Is there a parallel between what I'm talking about here and what you do in your work?
Yes, some of the stages correspond to how we do our work, but sometimes to not so doesn't. Maybe we don't follow the right stages or the right phases. For instance, the form in which the data may arrive, being it soft or hard copy, or even the template that they will use in the reporting, we may from the beginning not give them a template. So different institutions or different individuals create their own formats and submit. So when it comes, then there is another work to be done in processing it until you get a uniform data that you can then collate and begin to use. But I think this lecture is giving us the very right systematic approach in collecting and analyzing data.
Okay, so basically what you're saying is that a big part of your data cleaning work is, before you can actually start working on it, is to, how do you call that? Harmonize data that was sent in different formats.
Yes, yes,
Okay.
yes. That's
Yeah,
what
that's
sometimes happens. Yes.
that's
Because,
exactly what I meant when I said that most of the work in data analysis is actually just preparing the data. I bet that just, this step takes most of your time, doesn't it?
yes, it does. Yes, it does. Because different people understand different terminologies and different requests differently. So sometimes, as you are saying, we have to clean it, or in some cases you have to go back. You have to make a phone call, send an email, or go in person. So it's very good we have this systematic approach that will help us.
That's great. So actually what you're describing, where you go back and you call people or you send an email, is exactly this part that we're including here, which is called monitoring data quality. So you receive data and then you look at it and you're like, no, this does not seem right. And then you call people or you go visit and you're like, no, is this correct? Does this actually reflect the reality of what you are doing? So that is actually, it's just basically we call things different in different names, but the process is very similar. Okay, so and this is what and I guess that's what this slide is summarizing, that basically what we have called the different tasks here are just an abstraction for the purposes of understanding each other. And basically what we did is that we thought about how the data changes over time. But in practice, the work is, as you said, may be a little bit different depending on the kind of data that you're using. And also it's possible that some of the things that we have described here will happen at the same time, right? So for example, you're acquiring data and you're entering it at the same time. So data acquisition and data importing happen together. So these are just, ways to think about what we do. So the way that we in DIME organize our work is that, or that we organize our files in our folder, is that we think first of four different, four types of information. So we have one folder that is called data work that contains all the data related files in our project. So each project has one folder, and then each project folder has a data work folder. And we divide the files inside this folder into four different folders. The first one contains the data itself. So in the case of the project that we're talking about, this file, this recruiting cost file, and this HR dataset file, all of these would be stored in what we call the data folder, because this contains the data itself. Then we have another folder for the code, because we process data using statistical software through programming. This may not apply for everyone, so I will not get into a lot of detail about the code part. But then we have a folder called documentation that basically stores any documents about how we processed the data. So it is not the data itself, it is information about that data or metadata. So in the case of what we have done so far, this file with the data linkage table the data dictionaries, and also the data flow chart. All of these would be stored in a documentation folder. So if someone has a question about how the data is organized, they know to go straight to the documentation folder and look for this kind of information in there. And then we have a folder that's called output. And basically what's in this folder is the final documents that we are going to send out, the papers or the reports that we are preparing. So we will have images, we will have, you know, nicely formatted tables and diagrams, and we will have the Word or PDF file that contains the final result of our work. Inside the data folder, we will divide the data by the source of data, the unit of observation, and the stage of data work that we're in. What does that mean? I received data. Let's say that I received some notes from another government agency in a Word file, then I store them in raw. Everything that goes in raw is the very first original document that I received. And it's very important to have these documents stored and backed up, because we cannot recreate them ourselves. So the most important and most seminal part of our data is the raw data. We can redo the work that took us to clean the data, but we cannot recreate the data itself. It's going to be a pain. It's going to be a lot of work to re-enter the corrections that we made so that we could use the data together. But it's if I simply lost the raw data, then I could not even do that. So original data goes on raw. Then the clean data, which is the data that I have prepared to analyze, will go on this clean folder. So in the example that Daniel was talking about, in raw, I would save the emails that I have received with information. I would save the forms that people filled in. I would save them here. And then in clean, I would save the file where I have organized that information that was originally received. And I have tabulated it in a way that is consistent so that the information is comparable. So that would be saved here in clean. And then after I do these steps, so I create this final data set that we were talking about. There's a better picture of it. This final data sets here that I have, where I have calculated the averages, or I have combined my data, those I will save in the final folder. And master is just something that I mentioned before as well in the data map that I'm not sure applies exactly to your work, but it's a list of all the units of observation that you've ever found. So for example, if you need to remember what are all the government agencies and all the different codes that you use for each of them, that would be found in master. Okay, so basically what does that mean? Each stage of the data work, that is each step that we take when the data is modified, is represented by one folder, right? So we have raw, we have clean, we have final. And then each unit of observation will be represented by one file in that folder. So for example, here on the final folder, we would have, in the example that we were working on today, we would have 3 files. One that is final gender level data, the final source of recruitment level data, and the final position level data. And if you are receiving data from multiple sources, let's say, oh, I received data from the agency on the performance review of different people, and I received data from HR about the recruitment costs. So this would be stored into 2 different folders inside the raw data folder. Okay, questions so far? I'm gonna skip the code part because I don't believe that this is relevant for you. And the last thing that I want to talk about today is how we will organize documentation. So there's not necessarily a correct way to organize a documentation folder, because what kind of documentation you will have will depend a lot on your project. But I do want to talk about a few things that you should create for whatever project that you are working on. So the first one is a data dictionary, which is exactly this thing that we have created in here. So it's a list of all the information that you have on each data set and of the definition of the variables in that data set. Then you have a code book, which is basically a summary of the data that you have. So let's say if you have all this information here on employee name, age, pay rate, etc., then you would include things like, oh, for each of these variables, I have X number of observations, X number of observations are missing. This variable is stored as a number, or this is a categorical variable, or this is a text variable. So people know how to interact with your data when that comes. And another thing that is very important is to document quality issues and decisions that are made over time about your project. So for example, when we made a decision here about how to add up costs, we should write this down, and we should save this in the documentation folder in a file where we discuss how we calculate each of the final indicators. So we remember what is the definition of what we did and why we decide to define it like that. Or in the example that Daniel was mentioning, if we have to go back and call someone and ask them what happened to this data, then we should make a note and say, on this day, I, Daniel, talked to Luiza in that other agency to confirm that this data was correct, and they said it was not, and that the correct number is 10. So all the quality issues that you find and also how you resolve them should be included in there. And yes, and also things like the data map that we created would also go in this documentation folder. In the output folder, we'll have the final outputs that could include just the final documents, but also, separate tables and images that we have created. I think this is all that is relevant for you, because, oh yeah, no, the last thing that I want to talk, since we have 2 more minutes, is just for you to think about how you will track different versions of your files. That is, so for example, if you're making changes to the data and you need to remember that a change was made, this is what we call a version control system. And there are different ways to do that. The most common way is to use naming conventions. So for example, you save data set created by HR data set created by Luiza on created by Daniel on February 12th, and so on. How you choose to do version control is up to you, but what is important, and whatever system you use, it is important that everyone in your team knows what the system is and that everyone actually uses it. And in this sense, the best system that you can come up with is the one that everyone will use. I have other options listed here of version control that I'll share with you, but I don't think they are necessarily relevant for you as you are not using code.
Yes, Luiza.
Yes.
This version control is very important to me in the fact that we generate lots of reports, and sometimes we are unable to distinguish the same report which has gone through different stages of validation or different stages of finalization. Let me put it that way. So our level, we may have finished, have proofread, edited. We send copies to the agency or a draft copy for their comments and review, study and comment. They give us their feedback, and then we may go through another stage where we have a validation with OHCS, the ministry or agency, and other stakeholders. And so if care is not taken, you might not know which version you currently have. Practically, what I have adopted is to save the document with a date. And so I may have maybe Ministry of Health, October 2022. And I may have another version, maybe December 2022. So that the month will help me remember which one is the most current or the latest. I think this version control is very important because for some of us, we have a mini archive on our computer.
Yeah.
Yes.
Let me show you one suggestion that is what my team uses. Where's this? Here. So what we have here, so we have, this is a book that we created recently, and I'm just trying, okay, yeah. So this is the copy edits of the book. So we have different folders for different versions. So for example, copy edit rounds will go on the copy edit folder. And then you will see here that we have first round of copy edits. And then the file name is named as name of the file, then the initials of the last person to edit it, and then what this last person did. So it's clean and reviewed. And it's clean and the copy edit was reviewed. And then when it's the final version, so clean, reviewed, and then we add some more, final. And then again, the initials of whoever last reviewed it. So basically, whenever you are editing a file, this one is another. So this one was, I was the one to review it because it's my initials on it. So one way to do this is that whoever makes the last edit, instead of saving over a file, they just add, I did, in one word, I did this, and these are my initials. And then, yes, the file name will grow a lot, but it's better than not knowing which was the last one that was used. That is all from my side. Sorry, I know that we are already a few minutes past our time, but I can take another 5 or 10 minutes of questions if there are any left.
Hello, Luiza.
Yes. Hi, Alan.
I want to know which kind of statistical software would be appropriate for people within government like us when we are doing research. I know we use Excel a lot. So beyond Excel, what other software can be helpful?
Okay, so this really depends. It's depends on a lot of things. So I do not have one good answer, but it depends on what you want to do with the data. If you want to do, for example, a lot of statistical analysis, then Stata may be a good option. If what you are doing is just calculating averages and aggregating information, then I would say maybe you don't need to pay for Stata, because Stata is a paid software and it's very expensive. In terms of open source and free software, there's a lot of options. So you have R, Python, Julia. I think these are the most commonly used. There's also SPSS, but I believe SPSS is also paid. So it depends on what kind of data processing and data analysis you want to do, and also whether you're looking for a free or paid software, and how much you want to learn. If you're looking for a program that you can use through the user interface, or if you're looking to write code to analyze your data.
Okay, all right, thank you.
So sorry, I know I didn't answer, but I will say that Excel can do most of the things that you need to do, and it has a user-friendly interface. So I would say if you want to go past Excel, I would suggest that you start writing code. And then which code you will write is kind of a matter of personal preference. I have very strong opinions about it. I'm trying to not bias you based on my opinions. But that's something that I'm happy to talk more about as well, depending on what you are trying to do and what kind of training your team would like to do to learn a statistical software language.
Okay, all right.
Okay, Luiza.
Mm-hmm.
Where are we listening to you from? Where are you talking to? Where are you talking to us from?
I'm talking to you from DC, Washington, DC, in the United States.
Okay, that's wonderful. I really enjoyed your presentation. That's wonderful.
Thank you. I'm glad. I will send all the material to you so that you have it as well, and also the files that we created. Sorry, they're not super pretty as I was writing them as I spoke to you, but hopefully they will be useful for you to use as a model going forward.
Thank you.
Okay, thank you all. It was great to spend this 2 mornings with you, and if there are no further questions, I will hand it over to Adrienne in case there's any announcements that you need to make.
All right.
Thank you so much, Luiza. I don't think I have any announcements. Next Wednesday, we will be talking about translating some analysis into policy impact and have some case studies to discuss about that. and hopefully have a little bit of a lab session on Friday where we look at some data together, and how we might use Excel to analyze that data. So that's next week. Have a wonderful weekend, and we will see you on Wednesday.
Have a great weekend.